Okay, hello everyone. Okay, so now we'll be going through some of the homework questions, okay, for converse of Pythagoras theorem. Okay, so we are looking at 4 questions, okay, from exercise 8.1, okay, that I've given you. Question 11, 12, 13, and 21. Okay, so let's start off with question 11. Okay, so over here in this diagram, okay, they tell that QS is perpendicular to PR. Okay, and they tell that PS is 9, RS is 16, and QS is 12. Okay, so first they ask you to find what is PQ and RQ. So over here, since it's already established that this is right angle, so then in that case, QRS or QPS both are right angled triangles. So there isn't much to discuss about. So it should be pretty straightforward, okay, to practice your Pythagoras theorem. Okay, so let's begin. So in this case, they start with looking at PQS, this triangle. So they want to find PQ. So quick recap, Pythagoras theorem links 3 sides together. Okay, the sum of the square of the 2 shorter sides will be equals to the square of the hypotenuse, which is the longer side that's opposite the right angle. Okay, so in this case, PQ square should be equals to PS square plus QS square. Okay, so let's see. So in this case, they straight away do the substitution already. PQ square will be equals to 9 square plus 12 square. Take note, you need to write by Pythagoras theorem, okay, because if not, this doesn't pop out anywhere. You need to show me that you know that this is because you understood Pythagoras theorem. Okay, key into a calculator, 9 square plus 12 square, you get PQ square is 225. Okay, then after that, you need to perform square root on both sides. So PQ will be equals to square root of 225. Key thing to take note, okay, over here, they are missing a step. You should write PQ equals to plus minus square root of 225. And then you write that PQ is 15 cm bracket reject negative 15. Okay, so this is an important thing to take note, okay, when you're doing Pythagoras theorem, okay, is to when you're taking square roots, okay, to do a plus minus, okay. Then after that, once you know what is PQ, they also ask you to find what is RQ. So basically RQ, also a right angled triangle. So RQ square will be equals to RS square plus QS square. Okay, so RQ square will be equals to 12 square and 16 square add together. Okay, so RQ square is 12 square plus 16 square. Same thing, you need to write down this is because of Pythagoras theorem that you can establish this relationship. Okay, do your calculations. You realize that 12 square plus 16 square, when you key into a calculation, you get 400. Okay, then you take RQ square, take square root on both sides. RQ equals to plus minus square root of 400, you should get 20. So RQ equals to 20 cm, bracket reject negative 20. Okay, so please take note. Once you have that, let's look at question part B. Is triangle PQR. So this triangle, is it a right angled triangle? Explain your answer. So this is where the converse come in. Okay, so let's emphasize on how do you approach converse questions. Okay, you don't just straight away say that, a square plus b square equals to c square. You can't do that because when you're doing converse, okay, you're trying to prove whether something is a right angled triangle. So you cannot straight away say that a square plus b square equals to c square. You need to first calculate what is my c square. Then separately, you calculate a square plus b square, and then you compare the both of them, okay, to show that whether they are the same or not. If they are the same, then you can draw the conclusion that it is a right angled triangle. If they are not the same, then you draw the conclusion that they are not a right angled triangle. So in this case, if PQR is the triangle that we are looking, the longer side is clearly PR. Okay, so we are trying to establish that PQ square plus QR square. We want to check whether the sum of these 2 squares is equals to PR square. Okay, so we break down step by step. So first, I find what is PR square. So PR is just 9 plus 16, as you can see over here. So 9 plus 16, okay, 25 square, you get 625. Okay, so you establish that PR square is 625. Next, you need to find what is PQ square and QR square. So over here, you know that PQ square is 225. Okay, RQ square is 400. So you add them together. Okay, you realize that it is also 625. So now you know that, okay, this is same as this, so you can establish that you can conclude that it is a right angled triangle. But you need to tell me how come you can come to this conclusion. okay, because this is by the converse of Pythagoras theorem. Okay, so since I think there's a typo somewhere. Here there's a typo. This should be PQ, not PR. So since PQ square plus RQ square or QR square is equals to PR square, okay, triangle PQR is a right angle triangle, okay, by the converse of Pythagoras theorem. Okay, so you need to write that. Okay, if you don't write that, okay, yeah, we can't really fully award you the marks, okay, because that is one of the key understanding you should know. Okay, so with that, that's the first question down. Let's move on to the next question, question 12. So in triangle ABD, AB is 13, BC is 5, AC is 12, AD is 20. So actually over here you can recognize that, oh, I have a Pythagorean triplet already, okay? First, they ask you to find the length of CD. Okay, to find the length of CD, okay, we need to find a right angle triangle. We are trying to assume that ACD is a right angle triangle, but do we know that AC is perpendicular to BD? It is not given to us that this is right angle. Okay, so first I need to prove that this is right angle before I can treat this as is a right angle. So to prove that it's a right angle, since I don't really know this side, but I know this side, I can use this to prove that this is a right angle. So this means that AB square must be equals to AC square plus BC square. So let's begin the calculations. So AB square is just your 13 square. Okay, it's 169. Then after that we have AC square plus BC square. So AC square plus BC square. So you have 5 square plus 12 square. You should get 169. Then realize that, oh, both are 169. So since both of them are the same, we can conclude that AC is perpendicular to BD, or we can conclude that ACB is a right angle triangle, okay, with ACB being the 90-degree angle. Okay, so draw the conclusion. Since AC square plus BC square equals to AB square, okay, you can conclude that ACB is a 90-degree, or you can say it's a right angle triangle, okay, by the converse of Pythagoras theorem. Okay, so you need to write this down. Okay, for those who still not very sure of converse of Pythagoras theorem, let me re-explain here quickly. So Pythagoras theorem tells us that right angle triangle will always their sides are related, okay, by a square plus b square equals to c square. So meaning for a right angle triangle, I know the sum of the square of the two shorter side will always be equals to the square of the longer side. So if I know that that is the relationship of the three sides, if I can prove that any triangle, any random triangle I take and is able to satisfy this relationship where I take the square of the longer side and I take the sum of the square of the two other side, and if both of them are the same, okay, I know that by the converse, meaning if I do a reverse like logic, okay, I will also be able to prove that this is a right angle triangle. Okay, so there's a simple way of trying to explain the converse. What does the converse means? Okay, so now that you established that this is a right angle triangle, so I mean, yeah, this is a right angle, so this means that ACD is also right angle. Then you can proceed on to find what is CD, okay, using ACD is a right angle triangle. Okay, so let's see. So they say that ACD is also 90 degrees, okay, because the adjacent angles on a straight line, 180 minus 90 is 90. Okay, then you can apply your Pythagoras theorem, where AC square plus CD square equals to AD square. Okay, so AC square plus CD square equals to AD square. Okay, then you do a substitution. I don't know why they suddenly sub one of the values here, but that is your AD. Okay, so you sub that AD is 20, AC is 12. Okay, so 12 square plus CD square is equals to 20 square. So take note, this by here you are applying Pythagoras theorem already because you already proven the right angle. Okay, then to find CD square is just 20 square minus 12 square. Okay, you realize that you get 256. Okay, then you take the square root on both sides. Take note, CD equals to plus minus square root of 256. Okay, you get 16 cm bracket reject negative 16. Okay, I can't re-emphasize enough, okay, to always remember to do your plus minus and to reject the negative value. Okay, So once you have established that this is 16 cm, they ask you to find the area of ABD. Okay, so there is few ways to do it. Okay, we don't know whether ABD is a right angle triangle, so we can't straight away use half times 13 times 20 or half times 12 times. Oh, actually okay, we don't know BAD whether it's right angle, but we know ACD is right angle. So I can, instead of using half times 13 times 20, I can use half times 12 times this. So half times base times height. These two are right angle. Okay, remember just now we were saying to find the area of a right angle triangle, you take half times base times height, where the base and height must be perpendicular to each other. So in this case, I know what is this. This is 12. I know what is this. This is 5 plus 16. Okay, so I can do that. Half times 5 plus 16 times 12, you should get 126 cm squared. Okay, so yeah, half times this times this. Okay, I can't use half times 13 plus times 20 because I don't know whether this is a right angle. If I want to do that, I still need to prove. Okay, so it will become a longer step. Okay, so that is question 12. Okay, move to question 13. Okay, question 13 over here. Okay, triangle X, they say XYZ is a straight line. XY is 6, YZ is 4, TZ is 7.5, TY is 8.5. They ask you to show that YZT, this is 90 degrees. So they already given you the three sides. So same thing, you need to prove by converse of Pythagoras theorem. So you find what is YT square, then you find what is YZ square plus TZ square. See whether the two of them are equal to each other. If they are equal, by the converse of Pythagoras theorem, you know that this is right angle. Okay, so let's take a look. So same thing, we first find the hypotenuse square, so 8.5 square. Okay, so YT, so 8.5 square. Then I'll take 4 square plus 7.5 square. Okay, so YZ square plus ZT square is 4 square plus 7.5 square. You key in the calculator, realize that, oh, just nice, both are 72.25, so they're equal to each other. Okay, this means that, okay, by the converse of Pythagoras theorem, YZT is a right angle triangle. Okay, so over here, since YZ square plus ZT square is equals to YT square, okay, so then angle YZT is equals to 90 because of converse of Pythagoras theorem, or like the way I read it in class is by the converse of Pythagoras theorem, okay, angle YZT equals to 90. Okay, once we have that, let's move to part B. Part B, okay, so the converse part is now done already. Okay, the rest will just be your simple Pythagoras theorem. They ask you to find the length of XT. Okay, to find the length of XT, we know that this is a right angle triangle. I know this is 10, I know this is 7.5, I can find the hypotenuse. So by Pythagoras theorem, XT square will be equals to XZ square plus TZ square. So your XT square, your hypotenuse square, will be equals to 10 square plus 7.5 square. Okay, so 10 square plus 7.5 square. Take note, this is by Pythagoras theorem. Okay. Key into your calculator, you should get 156.25. Take note, take square root on both sides. So xt equals to plus minus square root of 156.25. So take note the plus minus and reject the negative. Xt is 12.5 cm. Okay, bracket reject negative 12.5. Once you know that this is 12.5, xt is 12.5, ask you to find the shortest distance from z to yt. So z is here, or ty is here, so the shortest distance here. So based on just now what we said, okay, the main approach to answering this type of question is understanding that the area is the same no matter how you calculate it. So area of triangle, we learned that for area of triangle, the half times the base times the height will be equal to area of triangle, and the base and height must be perpendicular to each other. So we know that this is perpendicular to this. So half times 4 times 7.5 will give me the area. Okay, then how do I find the z to ty? Okay, how come I can make use of that? Because even though I don't know whether it's a right angle or not, I know that the shortest distance must be a right angle. Can you imagine anything else to the left or to the right of the right angle will always be a longer distance already. So the shortest distance will always be perpendicular. Okay, so half times 4 times 7.5 will be equals to half times the shortest distance times 8.5. Okay, they are the same thing. So first you find the area, half times 4 times 7.5, you get 15 cm square. So we let the shortest distance, okay, be x cm. Okay, since we don't know what is the shortest distance, there isn't like a letter here for us to use. So we let it be x. So this area 15 will be equals to half times 8.5 times x. Okay, so 8.5 is this. So half times 8.5 times x. Okay, then you should get that x is 3.53 corrected to 3SF. So the shortest distance is 3.53 cm. Okay. Okay, we move to our last question. Okay, last question is not easy. Okay, it's an advanced question for a reason. So let's take a look over here. The diagram shows the plan of an office. Okay, they fill in the measurements. They say that PQ is 15, QR is 25, RS is 27, SP is 30. This is right angle, this is right angle. Okay, your SPQ is right angle, QRS is right angle. So explain why some measurements of the sides are wrong. Okay, so if this is a right angle, this is a right angle. If you join out SQ as a line, this gives you a right angle triangle. Okay, so PQS is a triangle, QRS is also a triangle. So this means that the two of them share a common side, meaning QS must carry the same value. Okay, so we can find QS in two ways. Okay, this since both are right angle over here, so QS is the hypotenuse for both of these angles. So I can first use Pythagoras theorem. I know this is 15, I know this is 30. Okay, the sum of the square of these two shorter sides will be equals to the square of the hypotenuse. Similarly, on this side, I take 25 square plus 27 square should be the square of QS. So so that's what I'm trying to say. So this square plus this square should be equals to this square plus this square should be equals to this, and both sides when you calculate should give you the same QS. So let's try. Okay, so using Pythagoras theorem, SQ, the hypotenuse square, will be PQ square plus PS square. Do a substitution, 15 square plus 30 square. Okay, you realize that SQ square is 1125. Take note, so SQ will be plus minus square root of 1125. Okay, SQ will be 33.5 meters. Reject negative 33.5. Okay, once you know that this is 33.5, next you need to make use of triangle QRS to perform the same calculation, see whether it tallies. Okay, if it tallies means that both of them are correct. If they don't tally means one of them must be wrong. Okay, so in this case, same thing. QR square plus RS square will be equals to QS square. So my 25 square plus 27 square. Okay, so 25 square plus 27 square, key into calculator. This gives you 1354. So QS square equals to 1354. Take square root on both sides. So QS goes to plus minus square root of 1354. Okay, you get 36.8 meters. Okay, take note, remember, reject negative 36.8. So you realize that using this right angle triangle, I get 33.5. Using this right angle triangle at 36.8. They are not the same. Okay, so they should be the same, okay, because they are finding the same length. So there must be some error somewhere, okay. So since in both calculations the length of QS is not the same, there are some measurements, okay, that are wrong. Okay, so with that, we have answered part A. Part B asks us to, given that only the measurement of QR is wrong. So now they tell you, okay, yes, there's something wrong. This one is wrong. So they ask you to find the actual length of QR. Okay, so now if this length is wrong, then the QS that is calculated using this side will also be wrong. But the QS that is calculated using this side, PQS, will be correct. So I can use this QS as my hypotenuse. I know this is 27. I can find my QR. Okay, so QS based on what we have. Okay, it should be 33.5 or square root of 1125. So hypotenuse square is just 1125. Then QR square plus 27 square equals to that. Okay, bring this over, you get QR square equals to 396 plus minus square root. So QR equals to plus minus square root of 396. QR is 19.9 meters. Okay, reject negative 19.9. Lastly, the monthly rental of the office is priced at $15.40, okay, per meter square. Calculate the monthly rental of this office, giving your answer to nearest $100. So now if you know this, you can find the area of both. Okay, so find in two triangles. First find the area of this, next find the area of this, add them together. Okay, once you know the area in meter square, okay, you can convert it into the monthly rental. Okay, so they add up half times 15 times 30 plus half times 27 times square root of 396. So like I say, every time we carry down the value, don't use the rounded off value, use the original value. Okay, so how did they get this? Half times 15 times 30. Okay, because when you are trying to find area, half times base times height, they must be perpendicular to each other. So 15 and 30, half times this, whatever new QR they have found, times 27. Okay, so this is the new QR. You key in, you get 493.6 blah 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 blah. Okay, don't run off yet, okay, because you are going to use it to calculate. They tell you that per meter square is $15.40. Okay, so since there's 493 blah 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 meter square, you take this times $15.40, you get about this. Okay, don't just round off to the nearest cents, even though that's the usual thing you do. Over here they got say give your answer to the nearest $100. So to the nearest $100, okay, based on this, I'll just round off to $7,600. Okay, correct to the nearest $100. Okay, otherwise that is all, okay, for the converse of Pythagoras theorem. Key thing to take note, okay, is that when they never tell you there is a right angle triangle, even though it looks like, you cannot assume. Okay, you need to prove it, okay, then you can use it as a right angle triangle. Okay, so every time you are using Pythagoras theorem, make sure you write down by Pythagoras theorem, you know that blah 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 equals to blah blah blah. Okay, and then for converse, okay, how do you prove? You find the hypotenuse square, you find the sum of the other two sides, the sum of the square of the other two sides. Okay, you compare, if they are the same, then you can say by the converse of Pythagoras theorem, it is a right angle triangle. Okay, if not, that's all for this. Okay, so yeah, thank you, bye bye.